All right. Hello, everyone. My name is Franklin. Welcome to Comp 3430 Operating Systems. This section is the small section. The other section is full, and this one is like half empty. So it feels a little weird to be stuck in this giant lecture hall with a half empty classroom, but I don't know. That's okay. I think it's going to be good. I hope that you're all doing really well despite the cold weather. I hope that you have all had a really good and restful break over the last couple of weeks. I'm really looking forward to teaching this course. I don't really think of myself as a systems person. Like, this is not something that I did when I was doing grad studies, but I've come to love this course over the years. So I'm really looking forward to doing it again. So all the lectures that I do kind of look like this. I will start by talking about what I'm expecting you to be able to do by the end of the class. So I like to do a lot of this outcome-based learning. And so I want to tell you a little bit about what you should expect to be able to do by the time the class is done today. So by the end of today's lecture, what I'm expecting you to be able to do is know a little bit more about the class. This is the first class, so it's going to be more of an introduction to the course and the kinds of things that we're going to be looking at throughout the term. And the other thing that I'm expecting you to be able to do is, at a really, really high level, I want you to be able to describe some of the responsibilities of an operating system. And the way that we're going to do this today is by beginning to write a little C program and then starting to think about the kinds of things that our operating system is doing for us. So are there any engineers in the room right now? One, did you take 2160? Okay, so everyone in this room has taken 2160 already. So you all have some experience writing C programs. And you know about things like calling printf to print stuff out onto the screen. You also are very familiar, I'm sure, with the words segmentation fault. Yes, yeah. But when you call printf, you're asking the operating system to do something, and it does something on your behalf. And part of what it's doing is the stuff that we want to start thinking about in this course. So I want to take what you've been doing in 2160 with C and start to reveal a little bit about what the operating system is actually doing underneath to get a sense of what's going on under the hood. So first things first, hello again, my name is Franklin. You can feel free to address me as Franklin. My preferred pronouns are he, him, and his. My office is in engineering in E2. It's E2 418. This is in the long hallway of instructors and profs. I'm at the one end that's closest to the quad and the main administration building. I'm going to have office hours this term on Mondays and Wednesdays from 9:30 to 10:30 a.m. And if those times don't work for you, I generally have an open door policy. If my door is open, that usually means that I'm welcoming visitors to come and ask questions about the course or anything, so please feel free to drop by. But I will also take appointments. If you want to guarantee that I'm going to be in my office at a time that's not one of these times, if this doesn't work for you, then send me an email and I'm very happy to make an appointment to meet with you. I'm also happy to take remote and virtual appointments. So if you can't make it to campus on Tuesday or Thursday, for example, I'm very happy to meet with you virtually on something like Zoom. This is my email address. Please use your U of M email address to email me. If you send something from a Gmail address, I know it's pretty easy to switch between the two on something like Outlook or Gmail on your phone. So if you do accidentally, I'll just politely reply and ask you to use your U of M email address. What I want to do now is just spend a little bit of time talking about the course. So the course homepage is on UMLearn. We're going to visit that in a couple of minutes. The prerequisites for this course are a mess. It's one of a bunch of different stat courses or physics 2496, and then 2280 plus 2080 or 2140 plus a couple of engineering courses. If you are in engineering, so thank you for identifying yourself. If you're in engineering, we recommend that you take 2160 before this. In the next week, like within this week, what I'm planning to do is spend a little bit of time doing a bit of a review of things from Comp 2280 and Comp 2160. Particularly Comp 2160 because with the assignments that we're going to be doing this term, I'm going to be reassessing you on some of the things that you would have done in Comp 2160. So for example, I'm going to expect you to do things like design by contract in your assignment submissions. So I want to spend some time talking about what that is because it may have been a while since you took 2160. And I don't want to just throw you out into the water with no flotation device. So the prerequisite list is a bit of a mess, but the general description of this course is operating systems, their design, implementation, and usage. We're going to be looking at operating systems. We're not going to be building an operating system. That's something that I would love to do in a course, but that's something that's more of a fourth-year topic. In this course, we're going to be spending time taking a look at the design of operating systems. So what do they look like structurally and like abstractly? What are they doing under the hood? So what happens when you call printf again, and then their usage. So we're going to be looking at certain APIs that we'll be using and then implementing a little bit of throughout the term. So I want you, by the end of this course, in terms of some high-level goals, I want you to be able to describe, implement, and analyze data structures and algorithms that are used in file systems. File systems are one of the first topics that we're going to be looking at. We'll start looking at that next week. I want you to be able to spend some time thinking about the data structures that are used in file systems. And they're mostly linked lists. They're mostly linked lists, but they're trees if you squint really hard and look at them in a certain way. I want you to be able to describe them and implement them. And I kind of want to just be able to think about things like how does an operating system take this file? Like I've got these icons that are on my desktop. How does it actually take that and put it onto a disk? How does it lay this out physically on the structure that we have that is our hard drive or the SSD that we've got in our system? I want you to be able to write and analyze concurrent programs. Concurrency is a pretty big topic in this course. Concurrency is this idea that our computers and our operating systems make it look like many things are happening at the same time. So modern systems, like my laptop here, has something like 16 cores in it, and it can literally just do many things at the same time. But for a really, really long time, computers had exactly one CPU. So if you think back to the olden days when Windows was still numbered in the 90s, so like Windows 98, for example, this was a time where we had exactly one processor. And yet, when high school Franklin was sitting at his computer, he could listen to MP3s that he had downloaded from Napster with Winamp, but also browse the web at the same time. Operating systems allow us to think that many things are all happening at the same time, even though there's only one physical resource that we're using at that time. Concurrency, we're going to look at this from a couple of different perspectives. We're going to look at this from the perspective of a single program that does many things at the same time, many programs that are all doing different things at the same time. The abstract idea of what this is, how to actually write code that does this, and then how to make sure that our code does it correctly. So keeping track of many different things happening all at the same time requires us to do things like make sure that certain things are not going to be changed all at the same time. Yeah. Related to concurrency is I want you to be able to describe, implement, and analyze scheduling algorithms and policies. So having this operating system make it seem like there's lots and lots of different things happening at the same time kind of requires our operating system to keep track of and decide who gets to go next. So who gets to control this physical resource that I have in my system right now. And then finally, describe and analyze strategies for managing memory. So we have all seen malloc. We've all seen malloc. We all maybe despise calling malloc because it often leads to segmentation faults. But our operating system has to do something about that. It has to answer the question, please give me more memory. It either has to say, here you go, or no, there's none left. But it's also doing that for lots and lots and lots of programs. And it has to make sure that these lots and lots and lots of programs aren't clobbering each other. They're not like writing memory in one program and then allowing that other program to crash that program. They want to make sure that everything is kind of separate. So an operating system has to do lots of stuff for managing the physical memory that's attached to a machine. The way that we're going to do that is we're going to be using C and Unix for this course. This is not a C course. This slide is almost identical to my 2160 slide. This is not a C course, so I'm not going to be teaching you C in this course. I'm kind of assuming that you will have done C at some point, again, specifically in Comp 2160. I will write a lot of C code, and so I'm going to hope that you are able to see the kinds of things that I'm doing and make observations about the kinds of things that I'm doing with C code to help refresh you about like getting that C coding stuff back up to speed. This is not a C course, but we're going to use C extensively in this course. Unlike Comp 2160, where it's explicitly not a Unix course, this actually kind of is a Unix course. This kind of is a Unix course in the sense that we're going to be learning about how Unix and Unix-like operating systems actually work. I'm not really going to be spending a lot of time telling you about how to use the terminal or the command line, but I'm going to be using the terminal and the command line extensively. We're going to be thinking about things that the terminal and the command line are doing for us and doing on our behalf, but I'm not going to be like teaching you explicitly how to do things like manage files on the file system on the command line. The development tools that we're going to be using are similar to Comp 2160. We're going to be using compilers and build tools, so we're explicitly going to be using make. I'll talk about this more when we're talking about assignments, but in terms of makefiles, I don't care how you make a makefile. That's not what this course is about. I'm going to ask you to use makefiles, but I don't care how you do it. You can steal mine if you want. You can use ChatGPT to make a makefile for you. I don't really care. That's not what this course is about, but I do want you to use make and build tools for that. We're also going to be using the command line, again, kind of extensively throughout the course. This is the textbook that we're going to be using for the course. This is called Operating Systems 3 Easy Pieces, and it's by Remzi Arpachi-Dussault and Andrea Arpachi-Dussault. This is a really good textbook, and I like it a lot. This is a free textbook, so at this address, you can find the PDF copies of this textbook. If you like a printed copy of the textbook, I encourage you to buy it from this website if you like to have a printed copy of things. The authors of the book are giving this away for free, and I think it's a pretty good quality textbook. It's free as in beer here in that it doesn't cost you anything to have it, but it's not free as in Libre in that you can't like take it and change it. They still own the copyright to this, and you can't make changes to it and re-release it under your own license, but they give it away for free so that you can just download it and read it in your web browser. I think this book is really good. I really like this book. I think it's a really good book. I think it does a good job of breaking things down into smaller pieces. I think it does a good job of taking high-level concepts and kind of making them approachable for a course like this one. I'm going to go so far as to say that I think this is a great textbook. I really, really like this textbook. The authors also sometimes have a sense of humor, which I appreciate, and I think that's important to help take some of these bigger, heavier topics and kind of add a little bit of levity to them. We're not going to be doing it in the same order that they have listed on their webpage. So we're going to be doing things in a slightly different order, but I'm going to tell you what the order of everything is as we're going through the course. You're going to be required to read chapters from this textbook, and generally you're going to be required to read these before you come to class. So there will be some stuff that I'm going to be talking about in class that will refer to topics that are in the textbook, but I'm not really going to spend a lot of time explaining those things. There's also stuff that's in the textbook that I will spend time explaining in class, but the expectation is that you're going to be reading this textbook before you come to class. I'm also going to give you advance notice, significant advance notice before we start talking about these things. So you'll have a good idea of what you're expected to read before you come to class and when you're expected to read it. All of the chapters that I'm requiring you to read, I'm giving you 2 additional things. All of them have reading notes that I've written. So like, as I'm reading this textbook, I'm just like jotting down my own notes about what I'm thinking about. To be clear, these notes are really, they're very stream of consciousness. Like, this is just what I'm thinking as I'm reading through this thing. Sometimes there's like questions that I'll ask that I don't give answers to because I don't have an answer to the question. Sometimes I'm like wondering why they're doing it in a certain way. Sometimes I'm pointing specific things out, like I think this is important and I like this idea, that sort of thing. The reading notes that I provide for these chapters, they don't really stand alone on their own. It's more of like, allow me to be your subconscious for a little while. As you read the textbook, you can see what I'm sort of thinking as I'm going through this thing. Some of the chapters will also have summary videos. So I posted a bunch of videos on YouTube related to the chapters for this textbook, but not all of the ones that I'm asking you to read. The videos themselves they're entirely optional. Like, this is not a requirement. I'm not expecting you to read my reading notes, and I'm not expecting you to watch my videos about the topics. They are just there for your extra help if you want or need that from those resources. So you're not obligated to read or watch the videos. Let's take a quick look at the course webpage. So I'm going to pop over here to our operating system section on UMLearn. There's a few different things that I want to point at here. So the first is the course syllabus. So I'm going to go to the content section here, and I'm going to go to administrative, under course resources, and I'm going to take a look at the course syllabus in ROAS. So this document is the course syllabus for this course, this term. And I'm going to skip over a lot of this stuff because we've already talked about quite a bit of it. But there's a calendar entry, there's contact information for me about where I am and when this class is happening. There's a general course description about what the course is. There's a list of detailed prerequisites, and what I've added to this is these are the courses where you can find these prerequisites from. So like I said, next class on Wednesday, we'll spend some time taking a look at this list of prerequisites and thinking about some of the stuff that you're going to need to be able to do from each of those courses. The course goals are something that we talked about already. I'm going to skip down here to the expectations and policy. This is just below the textbook section. In terms of expectations and policies, if you're feeling sick, please don't come to class. Please be respectful of everyone else that's in the room, and please be respectful of me. I am live streaming this section. I'm not going to live stream both because that would be kind of weird, I think. I think that would be kind of weird. I'm going to do the other section, but I'm not going to live stream it. I'm just going to live stream this one rather than streaming it twice in a day. So if you are sick, I'm trying to make sure that you have resources available to you to keep up with the course if you're not able to make it to class for some reason. If you are sick and you're not able to do coursework for some amount of time, the policy that I have for this is that I will grant an extension on assignments for up to 72 hours if you're sick and unable to complete coursework for any length of time. I require that you submit one of these self-declaration forms. You can send it to me by email, but I'm only going to accept one of these self-declaration forms throughout the term. If there's something that's causing you to be unavailable for a lot longer than 120 hours or 5 business days or what the self-declaration policy describes, there's other places where you can get support for things like that. So the policy in general is that if you miss a term test due to illness, so you're not able to make it to class on the day that we're having the term test, then I'll just move the weight of that to the final exam. If you're unable to submit an assignment on time, I'll give you an extension of 72 hours. So all of our assignments are going to be due on Fridays. That means the extension will be moved to Monday instead of the Friday that's there. If I'm sick, I'm not going to come to class. I have 2 kids at home. They're not really little anymore, but they still get sick. They don't always put things in their mouths anymore, but they still sometimes do. If I get sick because of my kids, I'm not going to come to class. I don't want to make you sick. And what I will do instead of that is either I will email you in advance to say we're having a class on Zoom today, or I will ask someone else to come and fill in. If none of those things are possible, then I might email you and say class is canceled today, but that's kind of a last resort sort of thing. In terms of class communication, please use your U of M email address to get in touch with me. If you have any questions about assignments and course material, so like how do I do this assignment, or questions about what the assignment is asking you to do, there are course forums that I put up on the course webpage. Please ask questions about course materials and assignments on the course forum. If I get an email asking about specific things about the assignments, I will politely ask you to put that on the course forum. My goal here is to try and make sure that everyone has access to the same information. So I'm not trying to like make sure that, I'm trying to make sure that one person doesn't get extra information from me just because they sent me an email. If you have questions or concerns about any feedback on assessments that have been given to you, so this is something that just applies to you, then please do email me. Please let me know. I'm always happy to take another look at an assignment assessment if there's something wrong with it, because I want to make sure that you're getting graded fairly and assessed fairly. So please make sure that you let me know if that's something that comes up. In terms of academic integrity, I'm expecting you to maintain academic integrity in this course. So everything that you submit is something that you have to write on your own. I'm explicitly calling out ChatGPT here. I've been finding that students are reporting to me that they're doing things like submitting their entire assignment to ChatGPT and asking them to fix it. ChatGPT is a good tool. To be clear, it's a good tool. It's an excellent tool when it's used appropriately. In terms of this course, I'm trying to assess your ability to do things. I don't really want to assess ChatGPT's ability to do things. That's an interesting academic question, but it's not really the point of this course. If you have any questions about, like, I can't get my C program working, please let me know. Like, you're paying to have access to me, so please take advantage of being able to access me and the TAs in the course. What you can expect from me in general is that I'm going to give your assignments back within a limited amount of time. So like before the next assignment is due, I'm going to give you term test feedback before the final exam. So this is before the end of the course. I'm going to try to use a variety of teaching strategies in the classroom, and I'm open to any suggestions for course material that you have. In terms of response times, my policy is 3 business days. Please remember that this is my job, and I try to maintain a work-life balance. So I don't really usually answer emails after hours, and I don't usually answer emails over the weekend. I try to get back to everyone within 3 business days. I don't usually miss that, and I almost always get back to people a lot sooner than that. But like I said, this is my job, so I try to make sure that I've got some kind of a work-life balance and separation of work and life. If you're registered with Student Accessibility Services, in terms of extensions and stuff, please come and let me know as soon as you can if you're going to take advantage of that so that we can work something out. And then in terms of the course assessment, there's going to be 3 total assignments in the course. They're weighted equally, so each one of them is worth 8% of your final grade. We're going to have one midterm test, and that one midterm test is worth 21% of your final grade, and then the final exam is going to be 55%. And the final exam will be scheduled by the registrar's office. The assignments are going to be due on these days, and the term test is on Valentine's Day. The term test is on Valentine's Day on February 14th. The final grades are kind of a standard grading scheme here. The one thing that's added here is that you must receive a passing grade on the final exam to earn a passing grade in the course. The other thing I want to point out on the course webpage is, if I'm going to go back to course resources here, the other important part is the course schedule. So this is the list of topics that we're going to be taking a look at throughout the term. The way that this document is structured is that every week is going to have an entry here that has like a title, a high-level description of what's there, a brief description of the topic in what I hope to be a little bit more of a readable approach, and then a list of the learning outcomes and required readings that I am looking for you to do for that week's material. So on Thursday or Friday this week, I'm going to add to this schedule the learning outcomes and required readings for week 2, but I do have some high-level idea of what you're going to be expecting to do for that week. The 2 readings that I have for this week they're optional. You don't have to read these things, but this is a good introduction to the textbook in general. It gives you a sense of what it's going to be like. In terms of the topics that we're looking at, the way that we're looking at these things is that we're going to take a look at file systems pretty early in the course. This is something that I usually leave until quite close to the end, but I want to do it closer to the beginning this time because it doesn't really require us to know too much more about anything beyond what we've done in Comp 2160. So when we're looking at things in Comp 2160, we're looking at implementing data structures, and maybe you did some binary reading stuff, but we'll definitely talk about reading and writing binary files with C. We're going to look at file systems, and then we're also going to look at file systems consistency and redundancy. So like trying to keep track of files on a hard drive and trying to make sure that the files are still going to be there as much as possible when our system crashes. Then we're going to move on to concurrency. So we're going to be taking a look at processes. This is a high-level concept in terms of like running programs on a computer. And then communication between processes, so how these different things can communicate with each other, send messages back and forth. Threads, so this is a finer-grained concurrency mechanism. Again, we'll talk about this a lot more detail as we get to it. Locking and deadlock, scheduling, so making sure that things are going when they're supposed to go. And then the way that we're going to finish up the course is taking a look at memory structures. So our machines have RAM in them. What does an operating system actually do with the hardware in order to make it available for us to use in the programs that we're writing? The last thing that I think I want to show you is that there's the discussion forums, there's the blanket honesty declaration. The other thing I do want to show you is this. So this is a link to the textbook that we're using, but this is also a link to a different textbook. This is the textbook for Comp 1002 and Comp 1006. This is a course. These are courses that are that we've introduced in the last couple of years that are like a lab course that do talk about how to use the command line and how to use build tools and that sort of thing. So I'm going to try to refresh you as much as I can while I'm going through stuff in the class. But if you are looking for things like how do I get connected with SSH, this would be a good place to remind yourself of how to do that. All right. So the next part of this is some general expectations. So I'm expecting you to participate in class. I try to do things that are a little bit more active than what we're doing right now, where you're just sitting there and I'm just shouting at you. I try to put some stuff in my class where I'm giving you an opportunity to give me some feedback. I will do a lot of live coding exercises, so I'm looking for you to code along with me as I'm going through some of these exercises. So please try to participate in class. Please do your own work. Please do your own work. Please do your own work. If you are going to use Stack Overflow, that's fair. I don't see any reason to say don't ever use Stack Overflow. If you are going to use something like Stack Overflow, use it carefully. So I like this example of using Stack Overflow. How do I find the length of an array in C? And if you find geeksforgeeks.org comes up first. That's our best friend, I'm sure. Yes. You can see that I've clicked on this before. And as I scroll down here, the first example here that tells us how to find the size of an array in C is maybe correct for this specific code sample, but it's generally incorrect. This is not the way that you can find the length of an array in C. In fact, you can't really find the length of an array in C at runtime. In C, you've got to like tell the function that you're calling how many elements are in the array. You must put that in your API. You must put that in your function signature. So using size of here works in this specific case, but then why would you do that? Because you can just look up one line and see that there are 17 elements in this array. It doesn't really make any sense. That's kind of like the thing that I used to tell students, use Stack Overflow carefully, but I mean, that's not something that everyone uses anymore. So I've added to this to use ChatGPT carefully. And so if I go to chatgpt.com and I ask it, how do I find the length of an array in C, it's going to tell me exactly the same thing. It's going to tell me exactly the same thing because it's trained on Stack Overflow. And when everybody has clicked this big shiny green checkmark button here that says this is the correct answer, ChatGPT is going to be like, oh, cool, that must be the correct answer. To ChatGPT's credit, if I scroll down a little bit further, it does tell us that we can't actually do that, but I have to scroll down in this answer to find out about that. It tells us that we should probably be telling functions that we call the size of the array that we're going to be passing to it. You can expect me to stick around after class for as long as is appropriate. I think there might be another class after this one, so I can't necessarily stick around in this classroom for too long after class. You can expect me to reply to emails and forum posts within a reasonable amount of time. I also promise that I will respect my office hours, but again, if those times don't work for you, then please just feel free to send me an email after outside of class time. All right, so I've spewed a lot at you in the last 30 minutes. What I'd like you to do is just take about 30 seconds to think about this. What do you want to get out of this course? Write that down on your piece of paper. You don't need to put your name on it. I just want to get a sense of what you're looking for in terms of what we're doing in this course. Write something down and then bring it to me by the end of the class, and I'll take a look at them all. All right, I'm going to keep moving. If you're not finished writing, that's super okay. Please just bring it up by the end of class with something written on it, and I'll take a look at, we'll take a look at them in next class. So what this course isn't about, this is not a course about C. I'm not going to teach you C. I'm going to write a lot of C, and I'm hoping that if you're forgetting C, then you'll learn a little bit more by osmosis, by what I'm doing on the screen, but this is not a course about C. This is a course that's a little bit about Unix and Linux, in the sense that I'm going to be telling you about the structures that are being used by the operating system. We're going to be learning a lot about what operating system is doing in terms of maintaining state and structures of the stuff that we have underneath, but I'm not going to be spending time teaching you how to use the command line. I will use Vim almost exclusively in this class. I'm not going to teach you how to use Vim. Nobody wants to use Vim except for me anyway, so yeah, take that for what it's worth. We are going to be doing everything in this course on Aviary. Your accounts have not been created on Aviary yet, but everything that you do for this course in terms of assignments will have to be compilable and also be able to run on Aviary. I'm going to do some examples of like connecting to Aviary once, but like I said, there's that extra textbook that I posted on the course webpage that gives some information about how to get connected to Aviary once those accounts have been set up for you. And there it is. Okay. So we're in operating systems. What does an operating system even do? What does an operating system even do? I want to write a little program in C. I'm going to do this just on my own laptop. If you've got a C compiler installed on your machine, you're more than welcome to follow along with what I'm doing. I want to write a little C program. This C program will do nothing important. It's not going to do anything meaningful, but it's going to do a bunch of stuff that will tell us a little bit about what an operating system might need to do. As we're writing this program, what I want you to be thinking about is, what are we asking the operating system to do? So I'm going to write this code. I'm going to tell you a little bit about it. I'm going to look at the manual pages as I'm writing the code to get a sense of what the function calls are supposed to look like. But I want you to internally be thinking about, what are we actually asking the operating system to do? The other thing I want you to think about is, what does the operating system need to keep track of on our behalf as it's doing the things that we're asking it to do? So our program that we're writing that doesn't do anything meaningful or important is running on a computer that has an operating system. We have to ask this operating system to do some stuff, and it will do some stuff for us, but it has to keep track of things as we're writing that code, or as that code is running. So let's get started. I'm going to pop open my terminal here. I tried to check before class started at the back, but is this big enough for everyone to see okay? Okay, awesome. I'm not going to switch to a light theme. I don't want to blind everyone. I'm going to edit a new file, and I'm going to call this what.c. And I'm going to just start writing some stuff. So I want to have stdio.h. I want to have stdlib.h. And I want to have a main function. And I want to return exit success. I'm probably not going to write this every single time in class that I'm doing a coding example, but for today, I think it's fair to get started with this. So stdio is like printf and stuff like that. Yeah. I will post all the code that I write up on the course webpage. Yeah. Like I said, I'm not going to write this out every single time, though. I'll just start from a template or something at the beginning of class. stdlib gives me access to this exit success so that I can say that I've successfully exited from this program. The first thing that I want to do in this program is I want to be able to start opening and reading files. So the function that I'm going to use for this is a function that's called open. I'm going to use the manual pages to get the information that I need about how to use this function. So open is a low-level call that we can make to our operating system. Did you use fopen in 2160? Just quick thumbs up if you used fopen. Okay, awesome. Okay. Is there anybody that didn't use anything with files in 2160? Everybody use files? Awesome. Okay. Okay. Sort of.
I can't remember.
Okay.
I haven't been in university for 5 years.
Okay. You might have then. You may have. You may very well have. Okay. So I'm going to call this function open. What I like about the manual pages is that it does tell us like what we need to include to be able to make these function calls. So I'm going to include fcntl.h. And what I'm going to do is I'm going to declare this variable that's called fd. We'll talk about this more later, but I'm going to use fd to stand for file descriptor or file handle. When you were using fopen in 2160, you got a file pointer back. This is an integer as opposed to a pointer to some other kind of structure. So I'm going to say fd is equal to open, and I'm going to pass to it the name of this file. I want it to just read itself. And I'm going to say o_rd only. So this is saying I want to open this file, and I only want to be able to read it. So thinking about this in your head, what are we asking the operating system to do? And what does the operating system need to keep track of in order for us to do this? Don't say anything yet. Just think about this in your heads. What are we asking the OS to do, and what does it need to keep track of to do that for us? Once I've opened the file, I'm going to check to see if I actually opened the file. So if fd is not equal to -1, So we return -1 from this open call if I can't open the file for some reason. If it does not equal -1, then that means that I have been able to read it, or I've been able to open it. What I want to do next is I want to start reading parts of the file into my program. I want to start reading stuff. So to do that, I'm going to use another function that's called read. Notice quickly that I'm doing this as man2 read, so manual page 2 of section 2 read. If I just do man read, it's going to tell me about a program that's in the shell, but I want to be able to look at the code, the documentation for this function that's called read. So section 2 is where the documentation is for these functions. So I want to be able to read some part of this file into my program. So I'm going to have to add a new header. I'm going to include unistd.h. And then what I'm going to do is I'm going to declare this variable called ssize_t read, and I'm going to say read, I'm going to say bytes read. Bytes read is equal to read. I need to tell it which file to read from. So this is that FD, this is that thing, that pointer, that's a pointer-like thing. I need to read it into a buffer. Okay, so buffer is a word that I will be using to describe arrays of characters. That's ultimately what I'm trying to say as a buffer. And then what we need to do is a count. So I'm going to say that I want you to read 10 total bytes. I need to allocate a buffer. I need to ask for a buffer to be created for me. I need to create this array to read into. So I'm going to say this, char pointer called buffer. So this is a pointer to a character, and the variable's name is called buffer. And what I want to do here is I want to do dynamic memory allocation. So I'm going to say buffer is equal to malloc size of char times 10. So I want to be able to store 10 bytes in this thing. Okay, so stop for a second here and think. On this line, what are we asking the operating system to do? And what kinds of things does the operating system need to keep track of on our behalf in order to be able to do this thing? Don't say it out loud, just keep thinking about it. And then I'm going to move down to this bytes read and read, and I'm going to put buffer in here. I want you to read 10 bytes into this buffer. And then stop. What are we asking the operating system to do? And what does it need to keep track of in order to do that? I'm going to call another function here. This one is called lseek. This will allow us to move around within a file. So I can move ahead, or I can move back a certain number of bytes, or I can go to the beginning of the file, or I can go to the end of the file. So after I call read, I'm going to say that I would like to go back to the beginning of the file. So I'm going to say lseek fd, the name of the file, or the file descriptor. So this is the file that we have previously opened. I want to go to position 0 in the file at the beginning, and I want to choose seek set here. So these descriptions say I want to set to offset bytes, so I want to go to 0 bytes from the beginning of the file. Seek cur is wherever you happen to be right now, plus some number of bytes or minus. And seek end is relative to the end of the file. Okay, and then stop. What are we asking the operating system to do here? And what does it need to keep track of in order to be able to do that for us? I'm going to do one last thing here. I'm going to say, oops, I forgot to call free. And then I exit. So stop. I'm exiting. What are we asking the operating system to do by exiting? When I return from main, what am I asking an operating system to do? And then what does it have to keep track of to do that for me? I'm going to leave this code up to the side. And what I'm going to do here is I've got a little survey for you to be able to enter information. I can't keep this code up on the side. What if I do this? Yeah. What are we asking the operating system to do on our behalf? What does an operating system need to keep track of to be able to do these things? I have completely obscured the connection information for this. There we go. These are the important lines in the file anyway. You don't need to be comprehensive in your response here, but minimally point at what we're talking about, which line approximately we're talking about, and what you think the operating system needs to keep track of on our behalf. Okay, so there's buffer and path. The path, it does need to keep track of the path, so that's a good observation to make here. When I say I want you to open what.c, the program that's running has to know, like, relative to where am I actually opening this file. So our operating system does need to keep track of something about the running program in terms of where it is currently in the file system. The memory that was allocated, good, yes. So it does need to keep track of the memory that was allocated. This one is, buffer here is, we need to keep track of the memory that was allocated. And I'm going to expand on this a little bit. We got to keep track of the memory that was allocated. We also have to keep track of what memory isn't allocated so that we know how much memory there is left to be allocated, and if there's any free memory to allocate. The program stack, that's a good observation to make. But it's only a little bit true. Our compiler is actually responsible for doing a lot of the stack stuff. Now, this is going to be something we'll talk about on Wednesday, but think back to Comp 2280, where one of the assignments in that course was probably build a stack, do a call stack, implement a call stack. This is something ultimately that your compiler is doing on your behalf, but the operating system is playing a part of that. Line 6, the position of the file read. Okay, great, good, really, really good. When we open a file and I say read, when I call read again, the operating system isn't just going to start reading at the first line of the file again. It keeps track of where we were. I don't have to do that. My program that I've got here does not keep track of where I am in the file. The OS is keeping track of that on my behalf. The pointer to the file read, so that I think these are the two same sort of things. Memory allocation, good. Where in memory we're storing things, file descriptor, the current working directory, the size and location of allocated memory, where memory is and how much. Memory, yes, okay, good, yes, memory. It keeps track of a lot of different things about memory. The check character Unicode, I'm actually not quite sure what that means. If you're willing to self-identify and say what you mean by that. If not, that's super okay. Variables and variable type, the end of the file, okay, yeah, and where in memory the buffer is located, okay. So these are all great. These are all really good observations. The one key thing that I want us to see with this example right now, and we'll talk about this more on Friday this week, is the operating system is keeping track of where I am in the file. This is something that it has to do. It keeps track of that on my behalf so that I don't have to really worry too much about that. All right, so thank you all for participating in that. I've got like 30 seconds left, so we'll talk about this diagram on Wednesday. At this point, you should be able to know a little bit more about the course. You know where stuff is on the course webpage. You should have a reasonable sense of like the high-level topics that we're going to be talking about throughout the term and some of the policies that, that we've got in the course. You are now able to describe some of the responsibilities of an operating system at a high level. So mainly, again, the key thing that I'm looking at here is it's got to keep track of memory somehow at a high level. It keeps track of what's been allocated and what has not been allocated. It's also keeping track of information about the file that we are currently reading, or a file that we are currently reading. So it has to have some extra information that it's keeping track of on our behalf to be able to do that. That's it for today. Thank you all for coming out. Please bring your slip of paper up to the front, and then I will otherwise see you on Wednesday. Bye, everyone.